Hi and welcome to John's Maths book. In this video, we're going to be looking at the sine rule and the ambiguous case. If you like the video, then please hit the like button and I'd be delighted and honored if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. Let's look at the ambiguous case for the sine rule. Let's say we're given two sides of a triangle and an angle which is not the angle made between the two given sides. That is, it's not the included angle. Looking at our triangle on the left, we have two sides of length 7 and 5 and a 30-degree angle, which is not the included angle. Now let's assume that the side of length 5 is the radius of a circle and we draw that circle. As you can see, the triangle interacts with a circle at this point here and at this point here. And so we can draw another triangle with side of length 5 within the larger triangle. Let's separate these two triangles out. Let's call the first triangle triangle A and the second triangle triangle B. Both triangles have sides of 7 and 5 and an angle of 30 degrees, which is the non-included angle. Now let's look at finding angle alpha here and here using the sine rule. It'll be the same for both cases. So using the sine rule, the sine of alpha divided by 7 is equal to the sine of 30 degrees divided by 5. The sine of alpha is equal to 7 times the sine of 30 divided by 5. The sine of alpha is equal to 7 times, now the sine of 30 is 0.5 divided by 5. If you use your calculators, you'll see that that works out to be 0.7. So alpha is the inverse sine of 0.7. If we now sketch a sine graph for all possible values of alpha between 0 and 180 degrees, we get a curve something like this. At this point here, we get a value of 1, and that's equivalent to 90 degrees. And then if we take our value of 0.7 and plot that on the graph, and we draw a horizontal line across the graph, we see that it interacts with the curve twice, once here and then again. If we now look at the inverse sine of 0.7 degrees, we get a value equal to 42.43, which is here. So for triangle B, alpha equals 42.43. Now, if we look at our graph again, and we look at this distance here, it's equal to this distance here. So for triangle A, alpha is equal to 180 degrees minus 42.43. And that equals 137.57 degrees. So now if we go back to our triangles and label the angles theta, so theta is here and theta is here. So in triangle B, theta equals 180 degrees minus 42.43 plus 30, and that is equal to 107.57 degrees. And for triangle A, 180 minus 137.57 plus 30, which is equal to 12.43 degrees.